And number 3, we're evaluating or simplifying the following. So that means you want to cancel out what you can and leave yourself with just a simpler answer. Okay, so most of these will involve the inverse rule. So on A, you see is log base 7, and then 7 raised to 3x. Okay, so we see that the log base is the same as the base of my number. See, log base 7, same as the base of my number, 7. That means they're going to cancel out. That's inverse, which means my answer here is just 3x. All right, same thing on letter B. 10 raised to log of x plus 2. What's the base on this log right here when it's not written? It's a 10, right? So that's going to cancel out. Boom, which means my answer is x plus 2. That's right. Whoa. C. E raised to 2 ln of 8. Okay, before we can do anything here, that 2 is in the way of anything, right? So what I want to do is move that 2, using my log properties, into the exponent spot. So this is actually the same thing as e raised to the ln of 8 squared, right? Now remember, e is the base on the natural log. Okay, so this is the same thing as e raised to the log base e, which would cancel it out, leaving me with just 8 squared as my answer. But what's 8 squared? 64. That's right. And there it is. And then last one, D. This one's a little more confusing because what you want to do first here is move the 7 to the front using the power rule. So this is the same thing as 7 times log base 5 of 25. Then you want to evaluate log base 5 of 25. So what is log base 5 of 25 equal to? And that's going to be 2, because if you try to see what this says, this is asking you like this: 5 to the x. What is 5 raised to get 25? What would x have to be right there? 2, that's right. And which means this whole term right here is the same thing as 2. So that means we're looking at 7 times 2, which is 14. And that's your final answer.